Hello friends, welcome to SSP Math. In last video we already learned what is linear transformation, orthogonal matrix, orthogonal transformation. Then we already solved some problems on orthogonal matrix. Today we will start most important topic of this unit, that is eigenvalues and eigenvector. So first we will see what is eigenvalues. Okay, our syllabus contents are eigenvalues and eigenvectors and its properties. Okay, so the word eigenvalue comes from German and eigenwort, where German word eigenword, where eigen means characteristics. This is very important, where eigen means characteristics and word means value. So that this eigenvalue is also called as characteristics value. Now how we define these eigenvalues and eigenvectors? Suppose matrix A be a square matrix, means let A be square matrix, and a scalar lambda is said to be eigenvalue of matrix A if there exists a non-zero vector x. This is very important. If there exists a non-zero vector x such that Ax is equal to lambda x, such that Ax is equal to lambda x, means if Ax is equal to lambda x, then we can say that lambda is eigenvalue of matrix A and x is eigenvector corresponding to eigenvalue lambda. So eigenvector is always non-zero eigenvector. Here यहाँ पर mention there exists a non-zero vector x such that Ax is equal to lambda x, means simply what is eigenvalue? Eigenvalue is the representative of that matrix, means if we cancel here this xx, then we will get A is equal to lambda. Okay, so what is the work of eigenvalue? Instead of that matrix we can use its eigenvalue. Now how to find eigenvalue? For eigenvalues, first we have to consider A minus lambda I, means we have to find the characteristics matrix, and for that we have to write that characteristics matrix is A minus lambda I into x is equal to 0. This matrix is called as characteristics matrix. And for eigenvalues, from this we have to take determinant of A minus lambda I equal to 0. If we consider here this determinant of A minus lambda I equal to 0, this one, then we will get one polynomial in terms of lambda. That polynomial is called as characteristics polynomial. Okay, that polynomial is called as characteristics polynomial or characteristics equation of given matrix. And if we find roots of that equation, we get the values of lambda, that is in the form of lambda 1, lambda 2, lambda 3. That values are our required eigenvalues. Means simply for finding first eigenvalues, we have to write characteristics matrix A minus lambda into x equal to 0, and after that take determinant of A minus lambda equal to 0 and expand that determinant using this formula. Means if matrix is of order 2 by 2, then use formula lambda square minus s1 lambda plus determinant of A is equal to 0. If matrix is of order 2 by 2, this is very important. Then how to expand this determinant? Which determinant? Determinant of A minus lambda equal to 0 using this formula, that is lambda square minus s1 lambda plus determinant of A equal to 0. What is s1? S1 is the sum of diagonal elements of matrix, and sum of diagonal elements of matrix is called as trace of matrix. So this is for 2 by 2 matrix. If matrix is of order 3 by 3, means this one, if matrix is of order 3 by 3, then use this formula, that is lambda cube here, lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0. Means how we expand that characteristics polynomial using this formula, lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0, where s1 is the trace of matrix, that is s1 is the sum of diagonal elements of given matrix, and s2 is sum of minors of principal diagonal elements. Means जो डायगोनल एलिमेंट्स होते हैं उनके जो माइनर आएंगे, उस माइनर की जो समेशन होती है, दैट इज द s2, And determinant, how we find? Using given matrix. After getting determinant of a s2 s1 put here, then we will get one cubic polynomial and find the roots of that cubic polynomial using calculator or using synthetic division, or you can use any other method for finding roots. That roots are called as eigenvalues of given matrix. If matrix is of order 3 by 3, then it has 3 eigenvalues. If matrix is of order 2 by 2, then it has 2 eigenvalues. Okay, then by using fourth and fifth, means this and this, find eigenvalues of lambda and find corresponding eigenvector. Means we have to find simply roots of this. If we get root, then we get eigenvalues. Okay, now we have to find eigenvectors. So first, everybody understood this procedure how to find eigenvalues. हमें क्या करना है पहले? For eigenvalue, we have to take determinant of a minus lambda I equal to 0. Expand this determinant using this formula if matrix is of order 3 by 3, where S1 is sum of diagonal elements of A, S2 is sum of minus of principal diagonal elements, and determinant of matrix is, that is given matrix. After getting these values put here, then we get one characteristics polynomial in terms of lambda. Find the roots of that polynomial using any method. That roots are our required eigenvalues. So this is related to eigenvalues. Now we have to find eigenvectors. So for eigenvector, first we have to consider again characteristics matrix a minus lambda into x is equal to 0. Okay, is the eigenvector. No, this is the characteristics matrix. We have to find eigenvector capital X is equal to x1, x2, x3 and so on, corresponding to the eigenvalues lambda is equal to lambda 1, lambda 2, lambda 3. So how we find these eigenvectors? Suppose our first eigenvalue is lambda 1 equal to 1, second eigenvalue is lambda 2 equal to 2, and third eigenvalue is lambda 3 equal to 3. Means 1, 2, 3 are our eigenvalues, and we have to find eigenvector of each eigenvalue. So how we find? We have to put that eigenvalues one by one in characteristics matrix. For example, मेरे first eigenvalue है lambda equal to 1. Okay, lambda equal to 1 इसमें put करना है हमें a minus lambda into x equal to 0 में, and consider any two distinct rows. Okay, and from that two distinct rows write down two equations. That equations are, say, a1x plus a2y plus a3z is equal to 0. Means first row, after putting eigenvalues lambda equal to 1, suppose first row is a1, a2, a3, and first row से मैंने equation लिखा a1x plus a2y plus a3z is equal to 0. second row is, say, b1, b2, b3. Okay, so उससे equation लिखा मैंने b1x plus b2y plus b3z is equal to 0. So these are the two equations in three unknowns. And how we solve these equations? For solving this, we have to use Cramer's rule. Now what is Cramer's rule? Cramer's rule हमें use करना है, तो Cramer's rule के लिए हमें x upon determinant of equal to minus y upon determinant of and equal to z upon determinant of. Okay, so x upon determinant of क्या आएगी? First equation जो है उसमें से coefficient of y and z, that is here is first row, that is a2, a3, and second equation में coefficient of y and z is b2, b3. Okay, b2, b3, then equal to minus y upon coefficient of x and z, that is a1, a3 first row, and here b1, b1, b3. Okay, and equal to z upon coefficient of x and y, that is a1, a2, b1, b2, and then expand this determinant. After expanding, we will get here one value, here one value, here one value. That are the values of x, y, z. And after getting x, y, z, then we have to write eigenvector is equal to, using capital X is equal to, in column matrix x, y, z, and x, y, z की जो भी वैल्यू आएगी यहाँ पर पुट करो. So this is the method how to find eigenvector. Now there are some properties of eigenvalues. We can check our eigenvalues are correct or wrong. How? First property is, say, using these properties we can check our eigenvalues are correct or wrong, but we will see one by one property. So first property is here, For a triangular or diagonal matrix, this is very important. For a triangular or diagonal matrix, the eigenvalues are diagonal elements only. Means triangular matrix means, suppose given matrix is upper triangular given a upper triangular matrix or lower triangular matrix, then we can write directly eigenvalues of that matrix is equal to its diagonal element. और diagonal matrix even diagonal matrix में क्या होता है, नॉन डायगोनल एलिमेंट जीरो होते एंड डायगोनल एलिमेंट नॉन जीरो होते. ओके, तो जो डायगोनल एलिमेंट होते हैं वही उसकी आइगेन वैल्यूज होती. फॉर एग्जांपल यूनिट मैट्रिक्स इज ऑफ ऑर्डर 3/3 दी, तो उसके आइगेन वैल्यूज क्या आएगी 1 1 1, बिकॉज दैट इज डायगोनल मैट्रिक्स. मीन्स अपर ट्रायंगुलर मैट्रिक्स और लोअर ट्रायंगुलर मैट्रिक्स रही तो उसके हम आइगेन वैल्यूज डायरेक्टली लिख सकते हैं. Second property is, if lambda 1, lambda 2, lambda 3 up to so on lambda n are the eigenvalues of matrix A, then 1 upon lambda 1, 1 upon lambda 2, 1 upon lambda 3 up to so on 1 upon lambda n are the eigenvalues of matrix A inverse. Lambda 1 raised to n, lambda 2 raised to n up to so on lambda n raised to n are the eigenvalues of A to the power n. Means simply here, suppose 2, 3, 4 are the eigenvalues of matrix A, then 1/2, 1/3, 1/4 are the eigenvalues of A inverse. Okay, 2 square, 3 square, 4 square are the eigenvalues of A square. So using this property we can write directly. Then next property is, if matrix A is symmetric, then eigenvectors are orthogonal. Means if matrix A is symmetric, then its eigenvectors are orthogonal. Suppose x1 and x2 are two eigenvectors of matrix A and that matrix is symmetric, then we can say that x1 and x2 are orthogonal eigenvector. So what is meant by orthogonal eigenvector? When x1 and x2 are orthogonal if x1 transpose into x2 equal to 0. If x1 transpose into x2 equal to 0, then we can say that x1 and x2 are orthogonal eigenvector. Then next property is, trace of A is defined as the sum of eigenvalues of A is equal to sum of diagonal elements of A. We know that sum of diagonal elements of matrix is the trace of matrix, and suppose 3/3 matrix given and if we get its eigenvalues is say 1 2 3, then sum of eigenvalues is always equal to sum of diagonal elements and product of eigenvalues is always equal to determinant of matrix. Means using these two conditions we can check our eigenvalues are correct or wrong. Or sometimes suppose two eigenvalues given a matrix A given a something and two eigenvalues of matrix A are 1 and 2 and determinant of A is equal to say 6, then find third eigenvalue. This is the question. So that third eigenvalue is say lambda. We know that sum of eigenvalues or product of eigenvalues is equal to determinant of matrix. So 1 into 2 into lambda is equal to 6. So what is third eigenvalue here? Lambda is equal to 3. 6/2 is 3. Okay, so using this property we can find. Similarly we can use this property also. If two eigenvalues are given, with the help of this property we can find third eigenvalue, or using these two properties we can check our eigenvalues are correct or wrong. Then next property is the set of all characteristics roots eigenvalues is called also spectrum of matrix. Okay, then eigenvalues of symmetric matrix are real. Eigenvalues of a matrix A and A transpose are same. Means for example 1 2 3 are the eigenvalues of matrix A, then the eigenvalues of A transpose are also 1 2 3. So this is the concept how to find eigenvalues and eigenvector. In next video we will solve the problems on this eigenvalues and eigenvector. Thank you.